a very, very bright woman.
And I'm trying to put a lot of
Oh, okay. There's rocks up there too.
So I'm gonna enjoy myself by the fire here while I do. So first of all, thanks everybody for coming to the event. We're delighted that you could be here on one of the Wellesley Conservation Land Trust properties. There's a bunch more in. We hope you can enjoy it another time too. And hopefully, after I talk a little bit, when you're walking around, you'll be able to see and interpret a little bit more about what you do see. So the first thing to know about this spot in this whole area in Wellesley is that it is sort of exposed ledge. All the streets around here, you've got Cliff Road and Oak Cliff Road and Crown Ridge Road and Summit Road, and it's all that because this is bedrock that is right there where you can touch and feel and climb on it. And that bedrock is 600 million years old. It was formed when Wellesley and when Metro West and when lots of New England was formed about 600 million years ago, when an ocean plate started to go under another tectonic plate, and that formed a set of volcanic islands like you might see of the Aleutians or the Philippines, or possibly even as big as Japan. So that is what Wellesley was 600 million years ago. And when one plate starts to go under another, most of the earth underneath us is solid rock. It's not lava underneath because the pressure is too great for the rocks to melt. But when an ocean plate goes underneath, it releases a ton of water, and the water acts just like salt. You introduce salt, it weakens the bonds on the ice in the road, and the ice can melt. When the water gets released from the ocean plate going under, it weakens the bonds of the rock there, and that can form lava. And lots of that lava comes up and forms volcanoes, and you can see those over at Broadmoor, the lava fields, where I'll be giving a talk next week by coincidence. But here this is all granite. So if you look at these rocks that are exposed closely, they're all pink, and you can see different pink or white or gray crystals in them. And that's because that's the magma that stayed under there, and it all cooled underground. So it cooled really slowly, and crystals formed. And that's what made it easy to know that it's just about exactly 600 million years old, because all of that lava has little trace bits of uranium in it, and they can get, some of the crystals have a little bit of uranium, and they know that when they formed, there was no lead there, because lead doesn't form crystals like that. So as it decays through half-life, some of it turns into lead. They know that tells them, that's a little clock inside every piece of granite that allows people to date it really accurately. So that's how this in general came to be. It was an island volcanic chain for a while. Obviously, at some point, it smashed into North America, and that's how a lot of the eastern seaboard actually accreted onto what was a smaller North America continent at that time. And when it did that, they got giant, there's debate about whether it was Andes height above us right now or Himalayan height above us right now. But enormous mountain range here on the edge of North America when that collided, and then when Africa collided into Boston later. So Morocco, we re-separated, but that was another one. So there was a series of events where things plowed into here. So there was enormous mountains, and at that time, these were the roots of those mountains, the granite that's here. So it got lifted up from where it was lower in the earth, but it was still covered by mountains, and over hundreds of millions of years, those mountains eroded away, made a very fertile fishing ground off to our east coast, and became what we near what we see today. About 2 million years ago, the other big shaping event of this property, we went into an ice age, and for 2 million years there were glaciers grinding over this area, and this was the top of a ledge, so they were really grinding their way over here. They're picking up sand and gravel and cobbles and boulders, and all of that was being ground over here under a half a mile or a mile, up to 2 miles in some places further inland. So just enormous pressures as it ground down this bedrock, and you can see that in some of the shapes. The north side in Wellesley, it comes from the north, so the north side of the rocks tend to be kind of sloping up. They're more gradually, and then you get a cliff on the other side. So if you're sitting at the train station, some of the train stations, you can see that cliff that's right there, and that's because the glacier came grinding from one side, and then as it passes over these crown ridges or crests or whatever they are, the suction sucks the blocks of granite off the other side, so they split and they come off. So that side tends to be, the north side tends to be steeper, and you can even see it on a piece like this that I'm pretty sure north is this way, and so this side is a steeper climb than if you tried to climb the rock that's over on this side of the house here, which will be more of a gradual ledge. Lots of the rocks around here are granite. They're that pink and gray. You can see it looks a lot like the rocks that are exposed. That's because right when you're near the top of an exposed piece of bedrock, lots of the rocks that broke off right at the end of the glacier coming by are still here, and so those rocks probably didn't come from very far. But if you spot a rock in here which is yellow, or which is whiter, or which is a light gray, that may have come from anywhere. That might have been from Canada, that it came all the way, and just at that moment when the glaciers finally melted away, it happened to be here. Kind of, it was getting carried further south, and then it all dropped out of the glaciers here. So all of those little rocks around, as you see, as you walk around, or as you look on the street, you can see lots of them are the granite. Those probably came from like the house next door, and then the ones that don't match may have come from hundreds or thousands of miles away. The only other kind of rock here, but I can only find it in the driveway cut right there, but I'm told that it's visible if there's enough leaves blown away. When the continents split, so the lands crashed together right here near New England, and then they happened. It didn't have to split in the same place, but it did split very near the same place. And so we remained on the edge of that continent. When it splits, granite is super hard to crush. It's really strong, but it's not as strong when it's getting pulled apart. So in some places the granite got pulled apart when that was happening, and lava would come up, magma would come up, and then quickly solidify in that. And in different spots in Wellesley, like Devil's Slide, if any of you have been over there, you can see where there is gray rock in the middle of granite, and it's just like it's clear that, hey, something different happened here. And likely one of the things that happened, there's been 2 times that supercontinents have split right here in Metro West, and so one or the other of those times was probably where that dike was formed. And I can see it right over there in the driveway, but I wasn't able to find it as I walked around today. So that's a bit about the geology of this spot. I'm happy to answer questions, and please enjoy. Yes.
Can you kind of give some insight into pudding stone, how that may be formed, pudding stone?
Sure. So the pudding stone, very similar time frame. It was formed right after this. So the granite, you had granite, and you had volcanoes coming up, and as those immediately they come up, they immediately begin to weather back down, and the pudding stone, they now believe, is the rock that was going into the ocean, sort of the edge of that island chain. It's forming, getting mixed with silt and then cobbles of rock, and that formed a sedimentary rock of different kinds. Some places you can see actual rocks. You can see this particular granite. So immediately you can tell that it was right after that this was lifted up, that immediately began to form the pudding stone. And then it went through various bits of getting crushed and so on, so you can actually see some of those rocks kind of stretched and deformed within it. There's a really neat exposure over by the intersection of Route 9 and 128, the gorge there, which I'm Hemlock Gorge. It has got some really wonderful exposures to that.
I think there's a rock right at the corner of Dover Road and Grove Street that needed a sharp angle.
That's a terrific one too.
Problem Rock, it's called.
Yeah.
I think that has pudding stone.
It is pudding stone, and I'm told it's called Problem Rock because it was a problem set they would give the Wellesley College geology students to say, is this exposed bedrock, or is this a smashed pinnacle? Is it one of the rocks which was just moved 100 feet or 1,000 feet, or is it an erratic that was carried here from a longer distance? And I've got my guesses, but I've never checked with the geology teacher to find out if I'm right.
So what is a pudding stone?
So pudding stone is it's a rock where you can visibly see cobbles in it that can be like this big. So it's solid rock that they could actually build from. So it looks like, wow, I should chisel that and it should fall into pieces, and but it doesn't, because it's been under such great pressure. But it's really neat that you can see all the different rocks that make it up.
And it looks like pudding.
And it looks like pudding. So yeah, it looks like like you've got plums or something in your raisins in your pudding. Plums would be a little big.
Is Africa moving in relation to North America now?
Yes. So they still the split that split us from them is the Mid-Atlantic Trench, and it's growing. I forget how many centimeters a year, but it continues to grow right now, and they have basalt flows, and they create new ocean crusts there at that spot, and we get a little bit further away and a little bit closer to Asia every year.
My wife and I were in Iceland a couple of years ago, and one of the places we visited was the fault line between the North American plate and the European plate, and it's a sharp division.
Yeah.
Flat here, and then it suddenly drops like 50 feet, then it's flat again.
Yeah.
Very,
the division goes right through Iceland.
It's a very interesting place to be.
Yeah.
What was the stone you saw in the driveway that isn't granite? What type of stone?
It's got a. I'm thinking dolerite is the name, but it is usually just it's a very undistinguished stone. They crush it up and use it for road beds. It's a hard material, but otherwise not particularly attractive
What stone is
and it doesn't.
my driveway? What stone is it that you saw over there? What do you see?
The one that was covered in leaves that you couldn't see.
Oh, the one right here that
Well, the stone that you're talking about.
oh
That
so
you saw in the driveway.
So that is you can see the gray stone right there when you look in the driveway. So it's got the
My
got the
driveway?
granite. If it's this one right here, I can see it. it's got the granite if you're looking right from the street, and it's just got the pink and gray, just like everything else that you see as you're walking through here. And then there's a kind of mishmash where clearly it melted.
So which stone? I'm not clear.
right through.
Oh, where the sign is.
Right past the sign and into the driveway there. So if you look at this house right here, where there's someone inside, and then there's a cut for the driveway there, where they've cut some of the rock, and you can see it as you walk by. And out by the street, it's Dedham granite. And then as you look in, you can see that there's a mixture of something else where something came through and melted the granite. And then there's some gray rock there.
Well, I can attest to this being very hard.
It's-
Because the whole house is built on that rock.
It's-
And we're trying to dig it up.
Oh, it's impossibly hard.
Impossibly hard.
And it doesn't break nicely
No.
in any way, which is why it's a
no,
tough
it's
building
costing me a
material,
lot
because you can't
to get rid of it.
you can't trust that you're going to get a block out of it
No.
or anything. It just
No.
kind of chips and
Really hard.
really
They
hard.
said it's the hardest rock they've ever.
That's why they use it for road beds.
Yeah.
It is indestructible
Yeah.
even in
Amazing.
chips. So, but terrible to have to build on.
Yes. And the other interesting thing is when they were blasting across the street, or even one house back, I could feel the shakes because of the rock, and
Because
I figured.
it's one rock.
Yeah.
It's all one
and
rock,
it was
right?
coming from, nobody else felt it.
You could
Just
beat
me who was sitting on the rock.
You could beat a house on Albion might feel it when they're jackhammering here, because this is all one
Yeah.
connected piece of bedrock. And if your house happens to be right on the bedrock, you've got no.
I went out in the
then-
street and I'm looking at my neighbors going, is anybody else feeling it? And they weren't.
Yeah, it depends on whether
Yeah.
they're right on the bedrock
Yeah.
or not.
Interesting.
Just, I grew up on 7 Crown Ridge Road, right across the way here. Actually, my parents would have Gertrude Cronk over for dinner periodically, so I met her when I was very young and she was very old. But she talked about Deal's Quarry, and that there used to be a quarry between Crown Ridge and Pleasant where that steep cliff
I always
is.
wondered where that was.
Yeah, so that's where she said it was. By the time my parents moved in the mid-50s, it was, all being developed land. Pleasant was developed, Crown Ridge was developed, but she would talk about Deal's Quarry and the sort of the marshland, swampland where all the sprayed playing fields are.
Yeah.
And as a kid, I would pick blueberries in the backwoods between Pleasant and Crown Ridge, and there were lady slippers all over the place in there, so it was
Yeah.
a great place to grow up.
So the Dedham granite, if you cut it and polish it, can be a very nice looking stone, which is what this is all. It's named Dedham granite because that's the first place somebody identified it and named it, and this is the same formation through here from it. It tended to be a hard place. This is a hard place to quarry because we do have so many of those dikes, and then so you're trying to get this nice piece of granite out, and then you cut, and oh no, I've got this terribly hard and not splitting well gray rock that keeps intervening in the in trying to get a nice piece of granite to build with. I always wondered where thank you for
Yeah,
sharing
no,
that.
this is one of the things I remember her talking about when, I don't know why that stuff pops in your head, but it does.
Yeah,
I think Wellesley was named Dedham for a while.
it was part of
Dedham.
It was named Dedham, and then it branched. It was also encompassed Needham, and then Needham broke off.
then Needham broke off and we broke off from Needham, or is it the
No,
other way?
no,
Needham
the
broke off.
the West Parish broke off from Needham.
Yeah,
I'm in Needham right now, even though I grew up here, so foot in both towns.
yeah, great. Thank you.
When is your next month?